Okay, so picking up where we left off last time, I realized when I stopped the video last time that I forgot to run this last line about plotting the data. We can create a very simple box and whisker plot of this data just by using this plot function for the clover.dat. So I'm going to run that, and you see immediately it shows up over here in the plot window. If you want to see it a little bit bigger, you can just sort of move these panels around, and you'll see R scales everything appropriately. So this is a pretty nice representation of the data. We have our 6 treatment classes here on the x-axis. We have n-level on the y-axis, and we have the box and whiskers where the mean and the different quartiles are represented. And so you see here some justification for why we think there's a significant treatment effect. We do seem to have very different means across the 6 levels. We also looking here, there seems to be maybe some issues with lack of homogeneity of variance, and that's where we're going to get into in this next section. Incidentally, if this is a plot that you want to grab and pull into a report or something, you can come up here to the export function, and you could save it as an image, you could save it as a PDF, or you could simply copy it to the clipboard and paste into Word or something like that. And R makes it all quite easy. So I'm going to move that back over so we can go back to our script here. So we've run the ANOVA. Technically, you would not pay any heed at all to the results you get from an ANOVA table unless you have first verified that the data meet the assumptions of the test, and that specifically would be whether or not the residuals are normally distributed, and whether or not there's homogeneity of variances across all the treatment levels. What we're going to look at right now, we talked a little bit about normality using the Shapiro-Wilk test, so I'm not going to cover that now. We'll tie all this together into a full analysis probably next week. But what I want to focus on now here is using the Levene's test that I mentioned in lecture to test for homogeneity of variance. And if you'll recall, what the Levene's test is essentially just an ANOVA, not on the data itself, but on the residuals. And there are different variations of the Levene's test, whether you run the ANOVA on the absolute value of the residuals or the squared residuals, and we'll go through the different variations of that here. But the simple one, let's run this by hand. In order to run an ANOVA on the residuals of something, we actually need to find those residuals, and R makes it quite easy because it has a residuals function. And that residuals function is something you apply to the model object. So if you remember up here at clover.mod, we already said what we thought the underlying general linear model was. We think that nitrogen level is explained by the group that it's in. Well, that's only going to go so far. Remember, every individual is going to differ from its treatment mean by a little bit, and that's going to be error, or that's going to be the residual for that individual. If we apply this residuals function to that Clover mod object, we can extract all those residuals very easily. So I'm going to extract them and then store them in another object I'm calling clover.res. These are the residuals for the Clover dataset, and we can take a look at those. So clover.res, and you see we have 30 values, 1 to 30, and for every one of them we have a residual. This number is how much individual 1 differs from the mean of the group that it's in. 2, this is how much it differs from the mean of this group that it's in, and so on and so forth. Now what we can do is take those residuals and append them to the original data frame. And the way we do that is we specify the data set that we've been using, and now we do this dollar, we're gonna do the dollar sign. Remember that's how we grab a column, and we're going to grab the column res. Well, the column res doesn't exist right now. If you remember, this is the structure of our clover.dat dataset. It has 2 columns. It has a column culture and a column n-level. So when we specify a column that doesn't exist, what R interprets that to mean is that we would like to create a column called res. And so I want to create a column called res, and I want to assign to that column the values that we just found. So I'm going to do that. I'm going to send this line. I'm going to send that line to the console. Now, if we look at the clover.dat data set, and I'm just going to look at the first few lines of that data set, and to do that I'm going to use the head function. There's a head function that will show you the first group of lines, and then tail would show you the bottom, the last lines of a data frame. But if I do head clover.dat, what you'll notice is that now, in addition to the original 2 columns we had, we now have this 3rd column that is residual. And I'm going to start gussying that up a little bit. I'm going to create now another column that is the absolute value of the residual. So I have clover.dat abs res, absolute value residual. And I'm going to assign to that the absolute value of the residuals that we found. And to cover all my bases, I'm going to also create a squared residual column. I'm going to call it res2, and I'm going to take clover.res caret 2 and square it. And now let's look at our clover.dat data set. Now we have 5 columns. Culture and N-level, the original data. We have the residuals. We have the absolute values of those residuals, so obviously negative 9.42. We just drop the minus sign, and then we have the squares of those residuals. What we've essentially done is now in our data frame, we can now run an ANOVA where we still use culture as the classification variable, but instead of looking at differences in N-level across treatments, we can look at differences in residuals across treatments. And the way that looks is this. I can run a linear model. I'm down here on line 34. I can run a linear model now where instead of having N-level as the response variable, I can choose the absolute value of the residuals as the response variable, again, as explained by the treatment group that it's in. And I can ask for an ANOVA of that. And you'll notice here I've called this is Levene absolute values.mod. And I could do the same thing with Levene squared residuals.mod. Let's run this first one. He gives us an analysis of variance table, and what we see here is that it looks like we have significant differences in the absolute values of the residuals across treatment groups. Taking this all by itself, we would conclude from this that these data do not satisfy the assumption of homogeneity of variance. But don't be too quick here. It turns out that using the absolute values of residuals is not a particularly robust way of asking this question. It's fairly sensitive to departures from normality, and there are more robust measures than that. One improvement of that is simply to look at the squared residuals, and that's what I'm going to run up here. If we run the squared residuals model, what we find is that we get out of the dangerous territory. We are now at a p-value greater than 0.05, and so we would conclude from this that we actually have sufficiently homogeneous variance across treatment levels to believe the results of the analysis of variance above. Now, this is a lot of work to go in and manually extract residuals and then manipulate them somehow and then set up another ANOVA and interpret the results. It won't surprise you that R has some built-in packages that allows you to run a Levene's test in one line. And this is going to allow us, it turns out that this Levene's test in R is not part of the base packages or the base library of R functions. This particular function, Levene test, exists in a package called car. And so in order to access that package, in order to access that function, you have to install the package on your computer. RStudio makes this very easy. You can go over here to the Package tab, and you'll see there's this Install Packages button. If you hit Install Packages, and you type in car, and hit Install, RStudio will go out into the Etherweb and all of the pipes of the Ethernet, and it will find this particular package and do an automatic installation for you. Once you do that, I've already installed it, so I'm going to cancel here. Once you do that, it will show up in your list of packages, but you'll notice that the check mark, the box isn't checked. Once you have it installed in your system, it will always be there. But in any given session of RStudio, if you would like to use that package, it's like taking the book off the shelf, you need to activate it. And so I'm going to click it here. We're going to use the car package. And you'll see here it sends a message over to the console, the library car. In other words, take the car book off the shelf because we want to use the functions inside of that. And if you do that, suddenly this Levene test will become available to us. And we want to run a Levene test on our clover.mod object. And if we specify the centers as the means, this is calculating residuals in the way that I've been talking about, where you look at a residual is defined as how an individual varies from the mean of its treatment group. If we do that, you'll notice here that we get the exact same p-value that we got up here when we ran an ANOVA on the absolute values of the residuals. And so that's what the Levene test is doing. As it turns out, even better than using squared residuals, an even more robust approach to running the Levene test is using the absolute values of the residuals, but not calculated in terms of deviations from the means of the treatment groups, but in terms of the deviations from the medians of the treatment groups. And that, in fact, is the default function within the Levene test, or the default parameter within the Levene test function. And this is the one that we are going to be using in class. So if you send this to the console, we get it right here. I've run a Levene's test using the default, and we get a very high p-value. In other words, I would interpret this as meaning that we have satisfied the assumption of homogeneity of variance for this particular data set, so we could move forward. We would also need to test normality, of course, but we could move forward with interpreting the results of the ANOVA. In this script as well, I've tacked on a couple of things. There's other homogeneity of variance tests. Of course, every statistics grad student who publishes a thesis has to create their own test, and so there are many statistical tests out there. That you will see something called the Bartlett test. That is a homogeneity of variance test, but it's also quite sensitive to departures from normality. We have the Fligner test, which is a non-parametric test, so if your data indeed depart from normality, this is a test you would use. We're not going to be using any of these in this semester, but certainly you could Google homogeneity of variance test and you'll run into more information than you care to see. At the bottom of the script, this is only if you're interested. What I've done is I've manually gone through and calculated residuals based on the medians and run an ANOVA of the absolute values of those residuals to show you that indeed the Levene test in the CAR package is doing exactly that. It's calculating residuals based on medians and simply running the ANOVA. So that's where it's coming from. If you're so inclined, you can work through that code. And I think that's it. We'll pick up with the next example in the next video of a CRD with subsamples.